Good morning, everybody. Thank you so much for coming. I would like to start by thanking Dr. James Booth, not just for the wonderful introduction that we just heard, but in fact for nominating me for the fellowship, for the Harrington Fellowship, which in effect enables this event, which is supported by the Harrington Fellowship. I would like to thank the Communication Sciences and Disorders Department for inviting me and hosting me, and again enabling this event. To Dr. James Booth's laboratory and Dr. Bedores and Elizabeth Pina's Ablo laboratory for making this event possible, as well as Dr. Bharat Chandrasekaran for supporting, and their students supporting a lot of these events and activities. University of Texas at Austin is a jewel of bilingual research. I have found bilingual research colleagues in the departments of French and Italian studies, and in addition to the usual suspects in linguistics, departments of education, and truly all over this truly amazing campus. So thank you so much to the representatives of those various departments again for making this event happen, to the students from all of these departments, thank you for joining us today. And without further ado, I would like to introduce our first speaker today, Dr. Ellen Bialystok, who is a distinguished research professor of psychology at York University, an associate scientist at the Rothman Research Institute at the Baker Center for Geriatric Care. Dr. Bialystok's research uses behavioral neuroimaging methods to examine the effects of bilingualism on language and cognitive processes across lifespan. Participants of these studies include children, adults, patients, in an attempt to identify the mechanism by which experience modifies cognitive systems. She has published extensively books and scientific articles. She's a fellow of Royal Society of Canada, Society for Experimental Psychology, American Psychology, and many other professional organizations. And among many awards are the Canadian Society for Brain Behavior and Cognitive Science Hub Award, Hillam Prize for the Social Sciences, York University's President's Research Award for Merit, Donald Stuss Award for Research Excellence at the Baycrest Geriatric Center, the Dean's Award for Outstanding Research, and many, many other awards. Most importantly, Dr. Bialystok is an amazing colleague and a researcher, and we thank her as a field for bringing the bilingualism research to the 21st century and bringing the bilingualism research out of the depths of an esoteric sidekick to language processing or education, and rather really shining light that first and foremost, a lot of the speakers of this planet are not just bilingual but multilingual, and that the science of bilingualism therefore is in effect is part of the human development and human lifespan science, cognitive neuroscience, developmental neuroscience. It has a stance and a place as the main discipline, and not a sidekick to the esotericism of linguistics. So without further ado, thank you so much from the field, and thank you so much for being here with us today.
This is dead, right?
Oh no, it has a little button on the top. It's hard to see.
Yeah, and I pushed the button another. Hello, can you hear me now?
Are you going to stay here?
Well, I have nothing to attach this to, so I think I have no choice, right?
Okay.
There's a
These things are made for me. I just want to say.
You could stand at the podium if you wanted.
But then how am I going to advance my slides?
These people are communication experts.
Okay. Oh, is this on? Yes. Of course, first you have to start the slide. While Yulia is finding my slide, I want to thank Yulia very much for this event. I've known Yulia for a long time, but I learned something new about her, and that is when Yulia asks you to do something, there aren't two possible responses. There's only one possible response. And if you don't give her the expected one immediately, you just have to wait longer, but she always gets it. So thank you for persisting, and thank you for this wonderful event. All right, I'm going to give you a kind of an overview. I'm going to talk a little bit about the theoretical framework, why we study bilingualism, how we contextualize it in theoretical terms, and then I'm going to describe for you several very recent studies that we've done with children. Now, here's the main thing. We don't study bilingualism because of bilingualism or even because of language. We study it from this perspective because it is an intense human experience, as Julia pointed out, a very normal, intense human experience. And anything that we do repeatedly, intensively, and in a sustained way has implications for our mind and brain. So in this sense, the very act of using two languages sets up a context that potentially changes our mind and brain. And what could be more important or more powerful than that? So we study bilingualism because of its potential as a source of neuroplasticity. What does that mean? There are many human experiences that are widely accepted to lead to plastic changes in the mind and brain. We talk about the effect of musical training, the effect of formal education. There's even studies showing that if you learn how to juggle, it changes your brain. What happens is that these experiences reconfigure, rewire, leave their imprint on your brain. So you can think about this as something leaving an imprint on a plastic, malleable surface. Footprints on a beach tells you who was just there. The beach changes because of these traces of experience. In addition, if you're doing something repeatedly, if you're engaging in the same activity over time, that activity, that process becomes more automatic, it becomes more efficient, and it runs more smoothly. Now, my example here might be a little weird to any of you who are actually from Texas, but here's how I think about it. When you cross-country skiing through the snow, the first person through the new field of snow has a very hard time. But as these tracks get laid down, you easily glide through the tracks. So that's this efficient automatic cognitive system. And both of these effects are directly related to the experiences in which we engage. So, bilingualism is intense, it is sustained, it uses the entire brain, and it engages multiple cognitive systems. So why shouldn't it lead to changes in the mind and brain? Now, the key reason that bilingualism has this effect, the single truth about bilingualism is this. If you know more than one language and you use more than one language in some way, both languages are always jointly activated to some degree. Always. Even if you're in a context where one of the languages is absolutely irrelevant, it is alive and well in your mind. And that means there's conflict. So all of your language processing systems are constantly required to select. So here's your very technical description of two language systems in the brain. And what you have is this constant potential for confusion. But we know bilinguals don't get confused. So this means that there's some mechanism that is used to select and allow language processing to proceed normally in this context of joint activation. That mechanism has something to do with an executive function system, and I'm not going to be very precise about what it is. I'm going to show you some options. But it certainly involves attention. I think this is now increasingly clear. So, as with cross-country ski tracks and footprints in the beach, A bilingual is always using their mind and brain in a slightly different way from monolinguals, and these changes become embedded and thereby determine future behaviors. Now, I want to go back and look at this central idea regarding joint activation. If you were going to build a human brain and allow it to accommodate two languages, what you would probably do is take a brain, jam in 2 bits of languages, and then add a switch. So this switch would mean that you're using this language and the other one is out of the way, and then you change and so on, back and forth. That would be a really efficient way to do it. If you did that, the switch would rely on things like attention, inhibition, the switch turns off, inhibits the other language, shifts, and so forth. There's no evidence that that's how the mind is created. What we actually have is a mind where both languages are jointly activated. There is no switch. So to effectively speak one language in this system, you have to constantly manage attention between the two options while they're both alive and active. It's a much harder problem to solve. But all of the evidence, and I'm not going to review any of this evidence, so trust me on this or ask me later, all of the evidence is, oh well, I'm pointing to the second model, is for the spotlight model, not the switch model. All right. So what would this mean? Now, those of us who've been working in this field for a long time have been trying to find an explanatory framework for the mechanism. And when these studies first appeared in around 2000, there was at the time a very exciting new model of executive function from Miyake and his group, in which he argued that the executive function consists of 3 sub-processes: shifting, inhibition, and working memory, provided some evidence for it. And I guess particularly because it included inhibition, it seemed like a really good fit. So a number of us thought, this is the way to go. We can use this as a framework for conducting bilingualism research. But over the last 10 years, it's increasingly clear that the data actually don't fit this model very well. In particular, inhibition is not relevant. There just is no evidence that there's inhibition. If you think back to those 2 models, if both languages are always active, nothing is being inhibited. And the centrality of inhibition for this model made it really a poor fit. So what's a different way of thinking about it? Instead of having these 3 components that each have a particular role, you can take a model that, this is based on a model from Randy Engel. It's just another way of thinking about it. I think there's lots of problems with this conceptualization. But what I like about it is that there's no components. It's a continuum of attention, a continuum of effortfulness. He calls this working memory capacity or executive attention. I'm going to come back to that later. But the main thing to notice is that there are no components, there is no inhibition, there's degrees of effortful attention. So to what extent is this a model for what bilinguals do when trying to process language in the context of jointly activated systems? Now, I think the Miyake model would in fact be an excellent match had the switch been correct. But there is no language switch, and I think that rules out the Miyake model. This kind of continuous model really, to my mind, works much better if we need this continuous spotlight. Okay, that's the theoretical background. Now, if you think back to what I said in the first slide, if you're using these systems all the time, there should be consequences. You should get better at them. So if bilinguals are using these kinds of processes all the time, is there any evidence that they get better at them? What's the evidence that bilingualism actually changes minds and brains? So on this slide, I'm going to show you all the evidence. This is all the data for the entire field on one slide. Truly. Now, I think what's extraordinary about this research now is that it covers the entire lifespan. The connections among things are still not always clear. There's a lot of gaps and holes, but there is a story now that covers the entire lifespan. So we begin with infants. In the first year of life, before they can say a word, there is no productive language. There are now at least 3 really incredible studies showing that infants being raised in environments where they hear more than one language use these early attention systems more effectively, differently and more effectively than infants being raised in an environment where they only hear one language in the first year of life. Most of these studies are with infants around 7-8 months old. They know the difference between 2 languages based on visual cues only, no sound. They attend, if they're looking at a face, they attend to the mouth where important information is, not the eyes. Infants in monolingual homes don't do that till they're 1 year old. They can learn to change where they're looking in the environment to receive a reward, which is like a dancing puppet. So infants in bilingual environments in the first year of life are using their nascent attention systems more effectively than infants in monolingual environments. Those infants grow up and they become children. And here there's a lot of research that has shown both behavioral and some, not a lot, but Yulia has contributed to this research, some neuroimaging evidence for changes in young children who are learning or using 2 languages. Now, there's one kind of task for which these children never perform any differently from monolingual children, and that's response inhibition tasks. So a response inhibition task is things like, don't open this beautiful present, don't press the button, or don't do what I'm doing unless it says Simon says. All of these kinds of don't execute a response things, there's no difference. And yet other tasks that in the Miyake model are equally inhibition, like the ANT flanker task, bilingual children do perform better. So inhibition isn't explaining anything. But there's a reasonable body of research with children with both behavioral and brain studies showing that bilingual children are using these control procedures, processes more effectively. Children grow up and they become young adults and they go off to college and they take Psych 100 and they get hauled off to do experiments for 4% of their final grade. Now, there is now a very growing, robust area of research showing that if you take these Psych 100 students and you give them these little executive function tasks to do, like a flanker task or a Simon task, and you measure their reaction time and accuracy, monolingual and bilingual young adults perform identically. We've also found that. But if you look at their brains, things are very different. And there is ERP, fMRI, and structural MRI evidence all showing significant, reliable, and consistent changes in the brains of these young adults who are nonetheless performing equivalently on these executive function tasks. Now, those young adults continue to grow, they graduate, they have children, their children leave them, don't get me started, and they become older adults. And here, things start returning, because now, even if you give older adults these same conflict tasks, you start to get reliable group differences. I mean, I think it's obvious that when a green check means that there's a substantial number of studies. Every green check mark represents several studies at least, okay? So these effects come back. Why are they there in older adults and children and not in young adults? Because young adults are performing all of these tasks at about 500 milliseconds, which is very fast, and it's very hard to get that number down. All right, that's the evidence. Now, you may have heard that there's some controversy about this research, that there are some researchers who are claiming that none of these effects exist, and in fact, bilingualism has no effect on cognitive and brain systems. All of that argument, almost all of it, is focused on that group. And in particular, it's focused on that one kind of finding. So we know that young adults rarely show a difference in reaction time and accuracy on those tasks. We first reported that in 2005. But the rest of it shows these effects. So you need to consider all the evidence. So that's the story about the lifespan, the evidence, and how we interpret it. What I'm going to do with the rest of the talk is describe to you several recent studies that we've done with children, trying to get in more detail a sense of how these effects are taking place and where we can find them and where we might not. Human development is never a one-factor model. It seems obvious, and yet some researchers like to pretend that it is. So the challenge is to figure out ways of studying development where we can look at bilingualism and, as far as possible, be pretty sure that we've controlled for everything else. It's very hard to do. So we want to look particularly at these, I'm going to call them executive function processes, because they are, even though it's not clear what exactly those processes are. They are very crucial in development. The development of executive function in childhood predicts lifelong well-being, wealth, health, success. These are really important processes to establish in childhood. So we would like to be as precise as we can. I'm going to begin with one possible other factor. So here we have an executive function ability. It develops in childhood. It's important. As I've already told you, bilingualism gives it a boost. So as these processes are developing, we have much evidence at this point that bilingual children are moving a little more quickly through that developmental trajectory. But there's another experience or individual difference that has the opposite effect. Children all vary in their natural ability to control attention, up to including clinical diagnosis of an attentional disorder. This varies through the population. And we also know that children with poor attention, up to and including a clinical diagnosis, perform very poorly on executive function tasks. So, what happens to children who have both experiences in their profile? Bilingual children who may have attentional difficulties. What happens when they combine? So we studied this in a sample of typically developing children. We want to see how this range of attentional ability plays out in bilingualism. Now, the interesting thing about bilingualism is that, unlike almost every other variable we study in psychology, it is not a dichotomy, famously said by Gigi Luck. Bilingualism is not a categorical variable. It just can't be. It's a continuum of experience. So, in the first instance, when we try to classify individuals dichotomously, we're losing a lot of information. So in this study, we took a large sample of children, just over 208 children, and instead of classifying them, we gave them a continuous score on a continuum of bilingualism and a continuum of attention. They're all typically developing children. None of them has received a diagnosis of attentional difficulty. Their bilingualism varies greatly, and we have lots of detailed information about how to assign that score. So what we're interested in is how their score on bilingualism and their score on attentional control each contributes to their performance on executive function tasks. That's boring. We gave them 3 executive function tasks, and we chose these because they all kind of make somewhat different demands. Now pay attention, because you're going to see these same tasks again later, okay? First, we gave the standard flanker task. It has conflict resolution or whatever. Lots of people use we did not use the ANT version. It's just the standard adult flanker task. There's literature showing that children with ADHD have a lot of trouble with this, and literature showing that bilingual children do very well with this. So we use a regression model, and we find 3 significant effects. The more bilingual children are, the better they perform this task. The better their attentional score, the better they perform this task. So here we have contributions from both. What about an interaction? Well, there was an interaction, but it was a little bit odd. Here's the interaction. The way to read this is, there is a fucking, okay. The red line is the mean bilingualism score for all 208 children. The attentional ability score is poor attention, great attention. These are just converted to standard scores. So poor attention, great attention. So if you take the whole sample, the better, and this is performance, the better children's attention, the higher their performance. If we split the whole sample by how bilingual they are, the blue line is the most bilingual, the green line is the least bilingual, so this is the main effect of bilingualism. There's an interaction because these are accuracies and they're kind of getting to the ceiling, so the effect of bilingualism diminishes. But you can see that both how bilingual they are and, not instead of, but and how good their attention is significantly contributing to how well they perform this task. Okay. We gave them a working memory task, and now we only have an effect of bilingualism. The more bilingual they were, the better they perform this task. This is a task where they see a matrix of squares, then they see these frogs jumping around. They have to remember where the frogs were, just spatial working memory. It's not timed. So having an attention problem doesn't interfere. We didn't time them on this task. We just looked how accurate they were. And the more bilingual they were, the more accurate they were. Where they were on this attention dimension made no difference. And finally, a stop signal task, which is a little bit inhibition, but it has a twist to it. So this is actually the gold standard assessment for ADHD. So basically, if a child cannot perform this task, they're well on their way to a clinical diagnosis of ADHD. Task hadn't been used with bilinguals, but we threw it in. And here's what we find, again, two main effects. Children who are more bilingual do better. Children who have better attention do better. In this case, there's no interaction. So again, bilingualism is boosting children's performance on all three of these tasks. They're all quite different from each other, but they're all under the general category of executive function. And having better attentional control also helps, but not instead. So it's bilingualism. So the summary here is bilingualism and attention both contribute to performance. There's no reason to have expected this to be a single factor model. Both have continuous influence. And I just want to interject that the continuous influence is a very important part of the argument, because remember, the framework here is experience-related plasticity, experience-related. If an effect is related to experience, then logically you would expect more experience to lead to a larger effect. If you want to learn how to play piano, you practice more. The more you practice, the better you get. So these dose-related effects that we are showing are really an important part of the argument that it's because of experience-related plasticity and not some sort of categorical shift that might happen at some point. So crucially for the bilingualism story, greater bilingualism was beneficial at all levels of attention ability. But the exact weighting depended on the task demands. So the untimed working memory task showed no effective attention, only bilingualism. Okay. And I think these data are very difficult to reconcile with those attention models. Here's the one problem with being up here. Okay, that's the first study. This is a recent study where we included some brain measures just to get a very different kind of perspective on it. This was a dissertation a number of years ago by a former graduate student of mine, Raluca Barak. She had 5-year-old children who were monolingual or bilingual, and we matched them as much as possible. More on those matchings later in another study. And we gave them some executive function tasks. We gave them the ANT. The bilingual children did better, replicating other research. But the one I want to talk about is a go, no-go task that they performed while we recorded their electrophysiology. So in a go, no-go task, you see a stimulus, and it's very simple. You see one kind of stimulus, you press a button. When you see a different kind of stimulus, you refrain from pressing a button. In this case, the GO trials were any white shape, and we changed them so you don't get these visual effects. So if you saw a white shape, press a button. If you saw a purple shape, don't press anything, all right? And it's always weighted so that there are far more GO trials, so you get into that kind of rhythm. And in fact, unlike some other research, and contrary to what I told you earlier about response inhibition, there are cases in which bilinguals actually do better on these tasks, and this study is one such case. So those are, I think those are D prime scores. The ability to discriminate between the trials where you are or are not supposed to press a button, and the bilinguals are doing better. The bilinguals on my graphs are always in blue. So monolinguals in red, bilinguals in blue. So the bilinguals are actually discriminating better. All right, but what about their brains? Now, the nice thing about Go No Go is that it's a really well-researched task in the adult literature. The electrophysiological properties of Go No Go tasks are very well known. And for adults, the main finding is that good performance, a really high-level, efficient performance, is associated with a particular waveform called the N2P3 complex. So there's a negativity about 200 milliseconds after the onset of the stimulus, followed by a positivity about 1 to 200 milliseconds later, and it's that clarity, the N2P3 waveform, that defines really good performance. There's hundreds of papers with adults showing that. There are also 2 papers with monolingual and bilingual adults showing that comparing those 2 groups of young adults, bilingual adults have greater amplitude on the N2P3 complex than monolingual adults. Okay, so that's the finding. That's what the performance looks like. What happens with 5-year-olds? I mean, they're really little. They're 5, okay? So we got it. Here's the effect. Now, this is a very cluttered graph, and I apologize for that. There is a larger N2 amplitude and a larger P3 amplitude. It's hard to see. The bilingual data are the blue and green lines. This is the N2, and negative goes up, positive goes down, just so you're totally confused. I don't know why they do that. But here you can see the blue-green is higher, here the blue-green is lower. So there is a significantly larger N2P3 amplitude for 5-year-old bilingual children than monolinguals. This means that as these kids are just starting to figure this stuff out, these executive function processes, these attention and control processes are really just developing. The bilinguals are showing more efficient, think about those cross-country ski tracks. The tracks are deeper for the bilinguals. It's more efficient, even at 5, even on a very simple task like this. Okay. So what have we got here? That for 5-year-old bilinguals, they're showing both better behavioral outcomes than monolinguals and better electrophysiology. Now, I want to just take a moment to say why generally we don't find response inhibition differences with children and adults. I think it's because we caught them here just at a point where they are beginning to be able to do this really easy task. I mean, it's really easy. Press a button or don't press a button. But if you're 5, this can be challenging. If we came back a year later, I think all these differences would go away because everybody would find this really easy. But in this period where they're just learning the task, the bilinguals are further along. And that's why I think the response inhibition is significant here, but is not significant in the majority of the literature. Most of that is with older children. And crucially, the ERP pattern that we found for these bilingual 5-year-olds is exactly what we find in the adult literature. They're not doing something weird, they're just developing more precociously. So their brain organization is already maturing. It's already looking like older children. Now, I suppose we could do this study with 6 and 7 and so on year-old children, but my prediction is that with a simple task like this, pretty soon these differences will disappear. So what are they doing differently? I can only think it's something like selective attention. Now, the task requires response inhibition, but I think that's far less important than the selective attention to these shapes. You see, white shapes or purple shapes, you've got to attend to them rapidly, efficiently, pay attention to the right feature so that you can respond or not. So I think the real challenge is not in responding, it's in attending. It's an attention thing. All right, next. It's long been suggested that all of these effects that we report in this literature are not actually because of bilingualism. They're actually because we don't control properly for other factors that are causing these effects. And the one that comes up most often is socioeconomic status. Now, it's interesting and deeply ironic because, as Yulia pointed out, there was the previous century Dark Days research where the conclusion was that bilingualism is terrible for children and makes them stupid. And in those studies, in fact, there were massive confounds with not only SES, but what language the testing was in. So they'd test children in languages they didn't know, and they'd find out children couldn't do. So this problem about confounding variables is a very serious one. And, you know, in the last, I'd say, 10 years, a number of challenges to this research have been proposed, suggesting that we still have not properly controlled for SES. So, in spite of the fact that there's now at least a dozen outstanding studies showing that that's not the case, I'm just going to show you one. I'm going to show you ours. I'll randomly pick a study, and I'll pick ours. Okay. This is a part of a dissertation by a former graduate student of mine, Alejandra Calvo. And she looked at the relationship between bilingualism and SES. And at the time, this is now not the only one, at the time this was the only study that ever varied these factors parametrically. So think about the attention bilingualism study where we're letting both of them vary. This is a similar model because we want to see if they interact. But this time we actually are going to make categorical classifications, not continuous. Other than that, the logic is the same. So we know, just as we knew for attention, that low SES is associated with very poor language and very poor EF. This is a large literature. It's reliable, just like attention is associated with poor outcomes. So what happens if you have low SES and bilingualism? What we're really worrying about here is whether or not there's been a confound in this literature. So we classified kids into 4 groups, and we did a couple of things to make our hypothesis very difficult to find. In the majority of studies, particularly studies conducted in this country, but also some studies conducted in Europe, low SES is defined as very poor, at-risk children who live in difficult circumstances. And in many cases, it's not surprising that these children have poor outcomes because they really are dealing with multiple challenges. So we thought if we really want to know if SES itself, in and of itself, is contributing to performance, we've got to make the distinction really subtle. So instead of middle-class kids and poor kids, we classified kids as middle-class kids and what we're calling working-class kids. The difference is simply how many years of education their mothers had. And particularly, the working-class kids had mothers with a high school diploma, and the middle-class kids had mothers with further education. Finding bilingual and monolingual kids in Toronto is easy. It's a highly diverse city where 46% of households in Toronto and the Greater Toronto Area do not use English or French as the language of the home. So bilingualism is everywhere. So we could classify kids as monolingual or bilingual and working class or middle class. But here's the thing. These kids went to the same schools. They all went to the same schools. Some of the schools in our sample contributed kids to 3 of the 4 categories. They have the same teachers, the same education. They play on the same soccer teams. So we really believe that all that's different about these kids is how many languages they speak, and particularly whether they speak English at home, and how educated their parents are. That's it. Subtle difference. So Alejandra gave them a battery of tasks, cognitive tasks. How smart are they? They're all exactly the same. These kids are all exactly as smart as each other. She gave them language tasks of various kinds and executive function tasks. And here we have, I'm going to skip this and show you the next graph because it's much better. We've converted all the scores to standard scores. So what you're going to see here is standard scores for the language tasks and the executive function tasks. And for the executive function tasks, we just collapsed across them. All right, so I told you that red is monolingual and blue is bilingual. In this graph, solid lines are working class kids and hashed lines are middle class kids. Here are the results of the language tasks, which are essentially vocabulary tests. They're standard scores, so lines moving up above the midline are higher than average and below are lower. So what do you see? You see 2 main effects. All red lines go up and all blue lines go down. And that's because monolingual children have better vocabularies and do better on language processing tasks in English than bilingual kids. You also see that the extent of the higher, this is the SES effect, the middle class monolingual kids do better than the working class monolingual kids, and the middle class bilingual kids do better than the working class bilingual kids. 2 main effects. Even with that subtle distinction, there's 2 main effects. If we look at the standard scores for the executive function tasks, everything is different. Now the blue lines go up and the red lines go down. So again, we have 2 main effects. Bilingualism makes everybody better, and being in the higher SES group, having more educated mothers, produces a second main effect. So SES matters, but it doesn't replace bilingualism. They both matter, 2 main effects. So, and then again, these are lower SES kids, but these are not kids at risk, and yet there's still effects. This is the last study I'm going to talk about, and now I am going to move into an at-risk population. This is a study that we did in California, in Central Valley. This is a population, I've been talking to Kenji Hakuta for years, like maybe a decade, about studying this population, and we really just could not come up with a design. But what I wanted to know was whether being more bilingual in this environment of massive bilingualism but massive risk provided any help. So these are kids in very difficult circumstances. 2/3 of them are children of Mexican immigrants. All of them live in very challenging situations, but they vary in their degree of bilingualism. And we wanted to see if that actually made any difference. So I said all this. It's a small sample. This was a really hard study to get going. So I think for this kind of design, the sample's a bit small, but you'll see the results are clear, and I think really what we need is further research of this type. So these kids are sort of 8, 9 years old, something like that. And we gave them all those tasks. So you remember the tasks from the attention study? I said, pay attention to these tasks. You're going to see them again. Here's where you're going to see them again. We had a bunch of background measures, of course. We measured their English proficiency. They all speak Spanish, and I think the thing that really varies more is their English proficiency, but we had Spanish scores as well. So we calculated a degree of bilingualism score as a ratio between their English and Spanish proficiency. It's a bit rough, but it was, we had numbers for both of those things. So we're going to give them those 3 tasks you saw earlier, and then assess through a regression model the extent to which their performance on these tasks is related to some of the background variables we're measuring, what their English proficiency alone is, just their absolute English proficiency, and what their degree of bilingualism is. Those are the 3 main variables, and these are the tasks. So, beginning with the flanker task, and we have here a pretty reliable effect. I mean, again, there's 64 kids in the sample, but there's lost data, missing data, so it's kind of a moving target on the ends. But still, there's a robust effect showing that the more bilingual these kids are, which is the blue bars, the better they're doing on the flanker task. This big gray stuff, of course, is variance. It's unexplained. It's normal in this kind of research. And their background and, their level of English were not significant contributors. That's in line with what I showed you for the attention task. Second one is this working memory, spatial working memory. You remember on the attention task, there was an effect of bilingualism, but nothing from attention, I think because it's untimed. And that's what we got here. So again, kids who are more bilingual are doing better on this task. And now, you can see these other, this is a bigger chunk. This is a bigger chunk, but the reason it is because to make this easy to look at, I clumped together groups of variables. So that big green bar includes age, education, and intelligence. The majority of that 13.3% in green is from intelligence, but intelligence alone was not significant. So I clumped them together, and what I really mean is not, you know what I mean. Okay, and then the stop signal task. So remember, this is the funny one. This is a really odd task. We had a nice effect from bilingualism and an effect from attention in the previous study, and in this study we get nothing at all. None of our factors are related to performance on this task. So I think these are much more pilot or suggestive results than actual results, but I think it sets a research agenda. Let's go back now to these models I was talking about. The Miyake model has dominated research in bilingualism and cognition for about 15 years. It has dominated it. There, it happened again to me. It's dominated it to the extent that studies, thank you, actually lay out the design according to the Miyake model. Here's our test of inhibition, here's our test of shifting, and so on. And those studies don't often work out very well. So you could say there's something wrong with the hypothesis that bilingualism isn't creating these kinds of changes. Or you could say that there's something wrong with the model. So I think that the Miyake model does not really fit the data. And what we need is something that doesn't focus on these little components, but rather this kind of more continuous approach. And we've seen this environmental bilingualism beginning to exert its influence in the first year of life. There's nothing in the Miyake model, that can explain infant results. Infants don't inhibit a language. Infants don't have much working memory, shifting. All they do is attend. And they learn where to attend for the best payoff. So the notion that that three-component model can explain the bilingualism and cognition data fails most dramatically with infants. So I think it's the wrong model. And that brings us to this other model, which is not very well specified. I'm not saying that the Engel model is the solution, but what I do believe to be true is that the notion of executive attention is the direction in which we need to move. How do we measure attention? What are the factors that determine our ability to control attention and develop those systems? I think that's the more productive way. I think what's changing is attention. Now, attention is part of the executive function system, but it slices up the pie in quite a different way. So there's the lifespan again. And I think what's consistent, because the studies are different, obviously, the research is different, obviously. I haven't even talked about patient studies and the dementia studies where we find continuing effects of bilingualism as dementia begins to take hold. What is similar across all these things? I think it's the way attention is deployed and the way the neural basis of attention is wired. The way attention is deployed and the neural basis of that attention. That's what I think the consequence of this intense and sustained experience is on the human mind and brain. So what do we say about young children? Well, if there are two languages in the environment from infancy, we know that infants very quickly adapt. They adapt to this situation. They quickly discriminate between them. They set up categories that are meaningless at that point for children in monolingual environments. And this complex linguistic environment has the effect of tuning, shaping, promoting attentional processes because their environment is more complex. Why are middle-class children doing better than working-class children on various cognitive and executive function tasks? Because they live in more complex environments. There's more stimulation. There's more to look at. There's more to incorporate. That's what a complex language environment does. So they develop better networks for attention and control naturally, because that's how you adapt to this environment. Attention is part of executive function, but it's not equivalent to it, and there is no evidence that language is inhibited. None. There is no language switch. Language is not inhibited. What there is evidence for is some kind of better attention to focus. So, do a language environment shape attention? Those are the little footprints. You can see the traces on the sand. My friend and colleague, Jubin Abudalabi, says he can look at a brain. He can look at a brain, and after taking some measurements of cortical density, he'll tell you, he says, he's very bold, he'll tell you if the person is monolingual or bilingual. So those are the footprints. Now, equipped with better attention, then follows that executive function develops better. And that's the tracks. The tracks are easy because you're just doing this all the time, and it becomes more automatic. And again, bilingualism is just the experience that we're studying. This is what experience does. Experience is powerful. Bilingualism is a particular experience, but other experiences also have this incredible capacity. We are the sum product of our experiences, and how could it be otherwise? And I thank you. Those are my lab people at the moment. Those are my funding sources, and thank you very much. Any questions?
Thank you so much for such a wonderful talk. We do have a discussion at 2 in the afternoon, but we have 5 minutes for questions. So we'll open up the floor for a few.
Hi, thank you very much for this discussion. And I'm wondering about, this is very interesting, I'm wondering about adults that learn languages later in life, in their 30s or 40s. What do you have to say about that?
Right, okay, good question. So what happens later? Because I'm trying to make it sound like if you start in infancy, it just all falls into place. But there are some really interesting recent studies showing adults learning languages later in life. So a couple of points. First, if these are dose-related, experience-dependent effects, then strictly speaking, the more experience you have, the more you'll see these effects, even if they start later in life. There are, of course, limitations because it becomes harder to learn languages. It's much more effortful. We never become quite as fluent later in life. Nonetheless, we can do it. So, there are a couple of studies now. One we did and a new one by Thomas Bach and his group in Edinburgh, showing that if you take monolingual adults, in our case, it was young adult undergraduates. In Thomas's study, it was a range of adults, including people up to the age of about 70, in a pre-test, post-test design, where the treatment is intense language training. You measure performance and, in our case at least, brain responses pre-training, and there are no differences. And then you come in later and look at post-training compare groups, and the language-trained groups is beginning to show these effects. So even in adulthood and even in Thomas's study in older age, these things begin to emerge. Now, they don't emerge in the same way. These are, more muted effects, but you see the beginning of them. People often ask me, well, does this mean, if I'm 60 or 70, is there any point in even trying to learn another language? And I think you also have to look at this in a different way. The concept of plasticity is part of an even broader concept of cognitive reserve. This is the notion that you can do things to protect your brain and maintain cognitive function in older age. The simple rule is, if something is hard to do, it's good for your brain. If you just stay, involved in stimulating activities. So learning a language is really hard to do. It's really hard to do, especially if you're an older adult. So you're going to get a benefit, but it might not have anything to do with being bilingual. You'll probably never become bilingual if you start learning another language quite late in life, but you're still doing your brain a favor. So this is, you have to contextualize it in these larger issues. So yes, you get effects in adulthood and later. No, they're smaller and more muted. And finally, the benefits might have less to do with them being language effects than being stimulating activities.
I have a two-part question. I really like the idea that experience is variable, that bilingualism is a continuum, and you can see these effects depending on how bilingual you are. The way you're measuring it is proficiency across the two languages, right? A difference between sort of comparable proficiency across the two languages. Is that what you're doing?
No, we actually have a detailed 8-page questionnaire that gives us lots of information about their language use, their language proficiency, their language experiences. So in that last study, the California study, that was really a quick and dirty ratio. But typically we base our scores on really a lot of information.
Well, maybe this is just from not knowing enough about the measures, but so there's two different factors that I was wondering about. So in populations that have pretty good proficiency in both languages, there's still differences in the way they use the languages, and I'm wondering, like, there's people that code switch, there's people that don't code switch. So do those things also have an effect? And then the second part of the question is, if bilingualism is affecting attention, is this a permanent change, or is it something that changes with you as you change in your use of your bilingualism over your lifetime?
Okay, good questions. Well, the first answer is actually really straightforward. All of it matters. And there's an excellent theoretical paper that's currently on the market and is only beginning to get proper empirical attention. This is a paper by David Green and Jubin Abudalabi where they propose what they call the adaptive control hypothesis or model or something. And it just addresses your question. It all matters. I mean, this is what makes this research so difficult to do. How you use the language, how much you code switch, in what kind of environment, it all matters, yes. The second question, does it change? Yes. I'll just quickly tell you about a study we did recently. We were interested in whether these effects go away because your language situation is constantly changing through your life. It always changes. So we did this little study with 3 groups. We had monolinguals. These are young adults. These are basically Psych 100 students again. We had monolinguals. We had bilinguals. And then we had this third group that we called, forgive me if this is an offensive term, lapsed bilinguals. So these are people who used to be bilingual, but then they aren't bilingual. And we had a way of controlling for all that. So we have 3 groups, and we gave them our executive function tasks. And the main finding is this: the bilinguals do better than the monolinguals on our tasks. And the lapsed bilinguals, these kids who used to be bilingual, they're right in between. They're not statistically different from either of the other groups. They're in between. So these kids are about 20, and they stopped being bilingual about half their life ago, like when they were 10 or 11 or something. I suspect that if we came back in another 10 years, they'd look even more like the monolinguals. But if they resumed life as a bilingual, I would presume it would go back. So I think you're right. I think these attentional abilities and processes are also fluid.
We will have a discussion period, so save your questions. In the meantime, let's thank Dr. Bialystok for a wonderful presentation.
I just want to add, if I can, that unfortunately I can't be here for the discussion. So if you do have questions, maybe you can grab me in the coffee.
For the beginning. We'll be all set. We have a brief coffee break.